Microservices, getting a lot of popularity the last few years, thanks in large part to companies such as Netflix and Amazon, who have moved to quite extensive microservice architectures. They talk about the benefits being things like improved flexibility, increased performance, better resilience. A few years ago, I got a call from my customer, and he said that this site was becoming really slow and almost unusable in certain situations. And then about a week later, I got a call from the same customer who said it was not working at all. Today, I'd like to tell you about how this one particular situation led us on a path where we decided to adopt microservices. And I hope at the end of this talk, you can decide this. Are microservices something that you could benefit from? And if so, how can you get started? This is the application I was talking about. We deployed it about 4 years ago. It was a typical monolith, meaning one code base, everything deployable as one unit. And there was one feature in particular that our customer had asked for, kind of last minute, and we decided the best way to implement that feature was to find a third-party library. Now, unfortunately for us, because it was so late in our development cycle, and we were so close to deploying, we couldn't find something in the stack that we had decided to go with. However, we were able to find something written in JavaScript. So we knew exactly where to put that in the client. Didn't seem like a big deal at first. But a week after deploying, this bit of code is what started causing us trouble. And so that's when we started getting those performance issues. And then again, a week later, 2 weeks after deploying this and delivering it, the resiliency obviously was not quite there. So we had 2 options we were really considering at this point. The first one, rewrite the code in the language that our stack would accommodate. But this had 2 big drawbacks. The first being that time was a factor. We had not made a very good impression, having deployed only 2 weeks before and wasn't really very usable. And we were not sure how fast we could translate that code and translate it bug-free. The second issue was risk. Would this code continue to exhibit the same performance characteristics that it exhibited in the client? If it did, putting it on the application server would not only continue to be slow, but could possibly then crash the whole application itself. What we needed was a solution that would allow us to isolate this one particular library while buying us time to address the performance issues. What we needed was a microservice, a single application as a suite of small services, each running in its own process. And this is essentially what this looked like. It's like our own service out there on its own server, completely isolated from everything else. And this bought us a few things. First, the flexibility to continue using a third-party library, which did technically solve the problem, while not having to completely change our application stack. It gave us improved resiliency. Obviously, the client was no longer crashing, just made an AJAX request to our microservice and was happy to wait as long as it took. It also provided us the insulation that we needed to be confident that it would not affect the rest of our application server. And finally, it improved our performance quite a bit. As it turns out, code runs faster on a server than it does on the client. This microservice ended up being very easy for us to implement. It was Node.js. It was maybe 10 lines of code. And so it kind of encouraged us to do more microservices. But as we went along, we discovered not all of them were quite as easy to implement as this very first one. Now, the title of this talk is Microservices, a Double-Edged Sword. And we learned quite a few lessons as we went along the way. The first being atomicity. Now, as our ecosystem grew and became more and more complicated, so did our types of requests. So imagine writing to service 1, which begets a write to service 2 and then to service 3. What happens when service 3 returns an error? Doesn't actually complete. Do you have to roll back what you made changes to in services 2 and 1? On a monolith, this is not that big a deal. It's probably 3 writes to the same database, wrapped in a transaction, and if one of those writes fails, the whole thing gets rolled back. Rolling back those changes is not so easy in 3 separate systems. The second issue we faced was cascading failures. And by that I mean I'll write to service 1, which writes to 2, which writes to 3, and so on and so forth. And if that message that the server gets back is an error, the issue here is that as far as the app knows, the only application that it talked to is service 1. It knows nothing about service 2 and service 3. So because service 3 has some sort of error on it, anything depending on service 3 is now going to error out, which would be true in a monolith if these 3 services were 3 modules. However, the bigger difficulty arises when you go to try and debug that. Again, because the app has no knowledge of what else is going on behind the scenes. So digging into a log is not as simple as looking at your application log. You have to then go to service 1, and it's not there. Let's go to service 2. It becomes much harder to debug these issues. Which brings me to my final challenge that we discovered, which is monitoring. I'm sure most of us do some kind of monitoring, log aggregation, log analysis. But when you start monitoring a microservice architecture, as you begin to grow that architecture, it becomes much more complicated. And the answers that your logging has to be able to answer become more complicated as well. So for instance, you have 3 services, you're growing, but you don't just have 3 nodes. You probably have more environments, test environment, sandbox, production, and you're probably going to scale those services as well. So 15 services can very quickly become well over 100 nodes that you have to monitor. Now what happens when one of those nodes goes down, or several of them? Does it matter? Do you have to get paged in for this? Has it affected performance? Does the customer realize that these nodes have gone down? Are these errors going to be cascading? These questions become a lot harder to answer in a microservice architecture. So should you take the leap? I've told you about some of the ways microservices have benefited us, and some of the ways in which they can be quite challenging. So is your project a good candidate for microservices? Well, that depends. Do you need the added performance from doing horizontal scaling and purpose-built VMs? Do you need flexibility to choose the right tool for the job, be it a third-party library? Do you need to be able to deploy parts of application independently from one another? And finally, do you need the resilience of having code in isolation? If the answer to this is yes to any of these questions, and you're still unsure whether or not your application is a good candidate for them, consider this. Inside every large program, there's a small program trying to get out. So in order to do this, 2 steps. First, gather those things that change for the same reason and separate those that do not. What Bob Martin is talking about here is well-defined boundaries and a clear separation of responsibilities. Clean code. Doing this will essentially lead to a more modular architecture, hopefully. And the whole point of having a modular architecture is the ability to change out parts of that architecture easily and confidently. Step 2. If and only if you can have a modular architecture, then next thing you want to do is keep it simple. Identify common functionality between your applications. Now, we don't all have multiple applications, and if you don't, that's OK. Identify the code that is ancillary to the business purpose of your app. And by that, I mean something like user authentication or some sort of admin process, something that's kind of tangential to what your application has to do as a whole. Take those things, put it into a service. Start simple. It's important to remember that microservices are not a silver bullet. If you don't have any of the 3 needs, increased flexibility, resiliency, or performance, then going to microservice architecture is probably a mistake. It's probably a solution in need of a problem, and that's going to get you into trouble. Questions?
So you said that you had a couple issues. How do you mitigate distributed transactions, that sort of a thing, or what did you do to solve those problems?
So the first issue of atomicity. So on the slide, I had shown basically several calls to different services. The actual issue was that we were making several calls to the same services where most of this issue cropped up. So a user has 10 preferences. So post the first preference, post the second, third, and so on and so forth. We got around that by allowing bulk inserts and bulk updates. That solved most of our atomicity issues. As far as the cascading failures, we originally saw that when we distributed a single idea across multiple services. And in those cases, it was probably better that that single function should have been on one service. You've also mitigated by doing better bug reporting, bug error handling. So when something fails, you know exactly why it failed. It helps to have transaction IDs on all of your requests so that each cascading transaction embeds this transaction IDs from the log so you can see exactly where all the logical requests are coming from. So you can sort of track that down a lot more easily.
What was the service that you all needed code for?
It was a service that calculated differences between rich text. So calculating differences between plain text is easy. There's a solution in every language. But rich text that would maintain the HTML structure that the customer was creating, that solution did not really exist so much. So, yeah. Seth.
For discovery, so if you have a service that does user authentication, how does another service know its address? Or is there a discovery? Is it?
So our services, they're built for our own applications. So our services, we embed within them knowledge of where the other services live. These aren't meant to be enterprise solutions by any means. No. Kyle, you had something?
Yeah, did you have services hit different databases and have to mitigate transactions between those two? Like, we're actually going to run into this on our project here soon, where we don't want to insert something into Solar if it didn't go to a Laker graph. Like, if there's a failure in between there.
Right. So each of our services has its own database, because that's the way it's supposed to be. As far as writing to one database, if and only if some other thing happens, that's, again, the cascading failure issue. You got to make sure that if something doesn't happen, you don't trigger something else. Yeah.
So is it inherent in the microservice architecture that you do have cascading calls? It seems like they're not really atomic if they have to keep calling one another.
Sometimes. If you had some sort of authentication service, for instance, that might be a popular service that the other services call. They get some requests and say, oh, okay, who is this person? They call the authentication service, like we do on our applications now. We all have an enterprise authentication service we all call to. So if that authentication service goes down, yeah, that's where you get that cascading failures. Now, that was the most common thing we saw was with our authentication and authorization, things like that.
For your deployment model, do you guys actually deploy independently? Because I do see a lot of people, they just make microservices and then your releases deploy your 5 different microservices all at once, at which point it's basically just a monolith.
Distributed?
Distributed monolith
Yes,
system.
you've created a distributed problem. Yes, they all do deploy independently. When we first started out, because we were transitioning away from the monolith to some of these, there were a few deployments up front that were kind of like that. But for the last year or so, we haven't had really any dependent deployments. We can deploy them independently of each other. We just to make sure we maintain the same API so that, again, it's still there for the services that are still using them.
So you actually do it independently of them?
Mm-hmm.
Okay.
Yep.
Did you find any issues, like just in development, since the actual code bases are, from what I understand, separate repositories usually, from the static analysis standpoint, like to be able to control click, for instance, and realize that you don't have an object available for something you might be calling or something like that?
So as in one service returning some document that references a document in another service and it not being there? We haven't really had that issue. No, I mean, I know what you're talking about, referential integrity kind of thing, but we've not come across that issue, no. Yeah.
Did you have several different microservices in different repositories? How do you version that stuff?
So semantically, so there's in the URL, just version 1, version 2. We've recently gone to versioning the APIs. Originally, we didn't do that, but as we're getting more and more in there, we decided, you know what, let's start versioning these things just in case we ever need to make some sort of breaking change, and then we can migrate to the new versions of APIs as we go along.
What's the
the integration between the different microservices? Are you guys using ACP calls?
It's all REST at the moment. We need to go to probably a queuing service for some of them. But it should just be REST and queuing services for the most part. I mean, you don't want any complicated communication between these things. The communication should be as simple and dumb as possible. Yeah, so just REST is one easy way to go. Or am I on time?
Good job, Michael.
All right.